Hey YouTube, this is Brendan with QZac Prep, and in this video we're going to be discussing how you can find zeros from an equation, in particular how it relates to the SAT. So we know what an equation is. An equation might just be something like f of x equals, g of x equals, or maybe even y equals. So let's say we had the equation f of x is equal to 2x plus 7. Now, if we're trying to find a zero, what we mean by that is we're going to plug in 0 for our y value. So instead of f of x, I'm going to write 0 on this side. And then I'm simply going to solve for x. So I might subtract 7 from both sides. And I have negative 7 is equal to 2x. And then I can divide both sides by 2. And we would find x is equal to negative 7 over 2. Now, what this means is that negative 7 over 2 is a zero of the function f of x equals 2x plus 7. What that means is that when x is negative 7 over 2, the y value is 0. So we call this a 0. We might also call it a solution to this equation right here. And we could even call it a root, or we could even call it an x-intercept. So all of these words can be used interchangeably when talking about the zeros for a function. Now, instead of a linear equation like I have here, sometimes we're going to be asked about an exponential or a quadratic equation, or just really anything besides a linear. So let's say we had a quadratic equation. Let's say it was written already in its factored form. So maybe we had f of x is equal to x squared minus 4x minus 5. Now, this is in its expanded form, but if we were to factor it, we would find that this would factor into x minus 5 times x plus 1. Now, if I asked you to find the zeros of this function, this would mean that we would just replace f of x with 0. So we could say 0 is equal to x minus 5 times x plus 1. And this equation can be solved through the zero product property, meaning we're just going to set each of these factors equal to 0 separately. So we'd have 0 equals x minus 5, and we would have 0 is equal to x plus 1. Now adding 5 to both sides, you would find that x is equal to 5. Subtracting 1 from both sides, you would find x is equal to negative 1. So this means that your solutions would be the point 5 comma 0 and your point negative 1 comma 0. So we could say that the x-intercepts occur at these points. We could say that these points are solutions, or we could say that these points are zeros. Really, any of these would work just fine. Now let's say we had a slightly more complicated problem. Let's say we had something where the factoring wasn't so straightforward, but maybe we had f of x is equal to 3x squared. Let's do minus 6, and then let's do plus 7x right here. So something like this would be factored a little bit differently. The process for factoring this is described in another one of the videos that I've posted. But what we can do to start is multiply 3 by negative 6. So 3 times negative 6 is negative 18. Now I need to find two numbers that multiply to negative 18 that also add to positive 7. So if I think of numbers that multiply to 18, I think of 1 and 18, maybe 2 and 9, 3 and 6. And it turns out that if I use a positive 9 and a negative 2, that these two numbers will multiply to negative 18 while also adding to positive 7. So what that means is in this next step, I separate 7x into plus 9x minus 2x minus 6. Now notice how I've kept the first term and the last term exactly as they were originally in the problem. However, I've taken this middle term and I have split it into the two factors of the product of the first term and the last term, so negative 18, that added to that value, or sorry, multiplied to negative 18 and then added to 7. Now what I'm going to do is factor by grouping. So I'm going to put parentheses around this, and I'm going to put parentheses around this. And what I'm going to find is that I can factor a 3x out of this first term, and then I'm left with x plus 3. And I can factor a negative 2 out of the second term, and I would have x plus 3. Now, what I do is I notice that what's inside of the parentheses is the same, and this becomes one of my factors. So x plus 3 is a factor. And then I also take my first term and my last term, and I bring them together. So this would be 3x minus 2. Now, all the while, I've just essentially just factored this whole equation. So this whole time I have f of x, and f of x running down the left-hand side. But our end goal here is to find the zeros of this function. So as we mentioned before, the zeros happen when you plug in 0 for f of x, and you set it equal to the right-hand side, which has been factored. What I do next is I set each of these factors equal to 0. So we could say 0 is equal to 3x minus 2, and then also 0 is equal to x plus 3. Now adding 2 over to this side and dividing by 3, we end up with x is equal to 2/3. And over here, we end up with x is equal to negative 3. So we know that there are two solutions to this equation, or two zeros, and those values are going to be 2/3 comma 0, and then also negative 3 comma 0. And that's how we can find the zeros to a quadratic equation that's a little bit more complicated. Thank you for watching. Hope you found this video helpful.